x equals 1. So then, with absolute values, there is a chance that one of these could be a false root, which means that if you plug this back in, it will not give you 6.
Hey guys, Preston here. I'm here to tell you guys about rational expressions today, and we're working with functions here. So the problem here is x squared minus 1 over x minus 2 plus x plus 1 over x squared minus 4. Now if you can see, these two terms are difference of squares, so you have to find a common denominator. So this right here is x plus 2 and x minus 2. So this x plus 2 needs to be here, so we put the x plus 2 here. Now we rewrite this problem. We have x plus 1, x minus 1, x plus 1, forgot the 1 there, and put this all over x plus 2, x minus 2. Now we simplify. Now, since we can't simplify anything here, this is actually our answer. So, square this up, and that's how you solve rational expressions. Now that you can go back, you have your denominator here, and you have to find the restrictions. So, you put x plus 2 equals 0, and x minus 2 equals 0. So for your restrictions, you would get x cannot equal plus or negative 2, and that's all you have to do for solving rational expressions.
My name's Troy Stanius, and the problem I'm working with is x to the second plus 5x minus 3 equals 0. Roman numeral 1. If we were plotting this, the y-intercept would be negative 3. But we aren't, so I'm just going to move on. We go to Roman numeral number 2, x to the second plus 5x. And then we move the 3 by adding it to this side, to the side with 0 on it, and that would be 3. Then we have to have the boxes, so x to the second plus 5x plus it'd be b over 2 to the second squared. Yeah, squared. Should go right there, equaling 3 plus the same thing. And that would become x to the second plus 5x plus 25 to the 4th, equaling 3 plus 25 to the 4th. Then we would square these. That would end up being x to the second plus 5 over 2 to the second squared. Sorry about that. Kind of that was really sloppy. Second squared equaling square root of 3 plus 25 over 4. Right here we would want to have the same denominator, so we multiply 3 by 4 over 4, and then we go down to 6. This becomes, well, since it's squared, x to the second plus 5 over 2 to the second, that becomes just x to the second, just x plus 5 over 2, equaling 12 over 4 plus 25 over 4 squared. The next step is x plus 5 over 2, and that equals 37 over 4 squared. And we can't have a denominator that's a square root, so, whoa, there we go. This becomes x plus 5 over 2 equals square root of 37 over 2. Then we want to solidify the x variable. So, okay, we have x equals, well, it'd be -5, and since they both have the same denominator, it'd be -5 plus or minus the square root of 37 over 2. And that's the answer.
No, I purposely pressed it. But I think Mr. Fronte. That was my fault.